Hello, this is our part 4 of 5 on our little mini lecture transformation, section 3.5. We've talked about the vertical and the horizontal shifting. We've talked about the vertical and the horizontal reflections. And now we're going to be talking about the vertical stretches and the vertical compressions. These will be all of our transformations that we talk about. Part 5, I'm going to actually put multiple transformations all in the same function. But again, I'm trying to do every individual transformation on its own on these individual parts. So part 4, the vertical stretch would be if you let f of x be a parent function, g of x equals c, where c is just some number, times f of x will vertically stretch f of x by a factor of c if the absolute value of c, which again makes it sure it's 1, bigger than 0, is greater than 1. So basically, what the number in front, if it's like a 2, which is normally the case, or 3, or 4, or 5, but normally it is a 2. That's the number they usually put out there. Maybe it's a 3, but usually 2, 3, or 4 is what numbers they like to use a lot on these things. So f of x equals x squared, again, it's just another copy of this one, so I wanted to kind of put them closer together. So my g of x, my transformation that I want to apply is 2 times x squared, which is 2 times the function. And so what this is going to do is going to stretch the parent graph by a factor of 2, which basically means you take a point that's off the y-x-axis, and if it's 1 unit apart, then it becomes 2 units apart. Notice how my fingers went. 1, 2. 1, 2. If you go over the next one, it'll be 2, 4, right? Because it's 2 squared is 4, so it's 2, 4. If you do this one, it'll be 2, 8. It'll be way up there. So this one goes 1, 2. And if this one will be 2, 4, so it'll be 4, and then 8. So basically what happens, a lot of people call this, makes the graph look skinny. So, because it thins the graph out when you do this. So, this graph will look more narrow or more skinny. But that is a vertical stretch. So that's why we call it a stretch. It goes stretch out. So now that is one of them, the vertical, basically a vertical distortion. So this is a distortion. So it's not the exact same shape like the other transformations are. This one actually has the same generic shape. Okay, it's like standing in front of those mirrors that makes you look really, really skinny in an amusement park or somewhere. So that's what this one does. It makes you look really skinny. And so if you put a number in front of it, that's what's going to happen. Now, a vertical compression is kind of the same lines. It's another distortion. But let f of x be a parent function. G of x equals c times f of x. So you notice it's the exact same thing. We'll vertically compress f of x by a factor of 1 over c if the absolute value of c is less than 1. And the most common number they like here is 1/2. Sometimes they may use 1/3 or 1/4 or something like that. But what it does, it compresses the graph. It makes it look skinny. It makes it look really fat. It's like when you get one of those mirrors and you look really wide. You look like a short, stubby guy. So that's what this one kind of does. So this right here is kind of, it's kind of the standard graph. This one widens it out. It makes it look wider. If I extended this, if I had my arrows extend out, you would see more that this thing is actually what we call fat. It flattens the graph. And the reason it does, remember this one was 1 up 2. This one's going to go 1 and then now 1/2. It's half as much. This one here was 4. Remember this one went 4, 8. This one's going to go 4, 2. It compresses it by a factor of 1/2. Basically, it's going to take this y coordinate and take half of it. Why half of it? Because you're taking half of the y coordinate. So if the y coordinate is 4, then you're just going to have to become 2. So when you do it, it makes a distorted graph. It makes it look stubby. So this one here stretches it out. This one here makes it look kind of fat. But these are what I call distortions. The graph doesn't exactly make a photocopy, but it's one of those graphs that you can distort it. Then it looks the same shape. So like I said before in the previous part, if you was in one of those mirrors and you look really skinny and really fat, I can still tell you if I could do what you look like in the first place. And if I looked at that mirror image of you and you're skinny, a really skinny person, or you're a really fat person, I could still tell it's you if I knew who you were. So that's the idea. So this graph becomes really skinny, distortion. This graph looks really fat, still a distortion, but it's still a transformation. Remember, the definition of transformation is the movement or the distortion of a general shape, or what I call the parent graph. So, but anyway, so we've done vertical shifts, we've done horizontal shifts, we've done vertical reflections, we've done horizontal reflections, now we've done vertical stretches and vertical compressions, and there were two more. There were the horizontal stretches and the horizontal compressions, which we were not going to cover in this class. Now, part 5, which is our final part, will consist of a problem that will have multiple transformations in it. So I will probably try to do a vertical shift, a horizontal shift, a vertical reflection, and a vertical stretch or vertical compression. I don't know which one I'm going to do, but I'm going to do a stretch. I'm going to do basically 2 shifts, reflection, and either a stretch or a compression. We'll see. So stay tuned. The next one will be part 5.